So for laying out a compound curve using a deflection angle method, these are the objectives: to know the elements of a compound curve, and also to lay out a compound curve using the deflection angle method. And for the learning outcomes is to establish a representation of a compound curve given the ground from given data, and also to identify and compute different elements of a compound curve using the deflection angle method. And for the apparatus or equipments used for these are theodolite, range, tripod, measuring tape, and a flaglet. So for compound curve is a two or more simple curves with different centers that bend in the same direction, lie on the same side of their common tangent, and connect to form a continuous arc. And for the uses, to have a better fit to the road center line to difficult topographic conditions, and also to avoid some control or obstacles and this cannot be relocated, and lastly, to avoid right-of-way problems.
As you can see in the figure part, the compound curve is composed of two simple curves, one from the point of curvature or PC to the point of compound curvature or PCC, and the other one is from the PCC to the point of tangency or PT. According to our estimates, the first simple curve consists of 18 stations, whereas the second simple curve consists of 7 stations. All these stations from station 1 to 25, including the PCC, is separated by 20 meters. On the other hand, the distances between the PC to the station 1 and between station 25 to PT are less than 20 meters.
Moving on to the procedure. This is the data we were given to solve using by chord basis. Substituting the given data to the chord basis formula, we were able to get the values of the radius and the length of the curve for the simple curves. Adding LC sub 1, which is equals to 360 meters, that is 360, and LC sub 2, we will get the length of the compound curve, which is equal to 509.89 meters. This is 509.89 meters, and then with this information, we can use this to solve for the long chord and the tangent distance of the simple curves, as you can see here. You can also use it to solve for the middle order distance or the external distance. Moving on, to solve for the stationing of PC, we will first get the tangent distance for the compound curve, that is by adding this tangent distance in the first curve and to the distance of AB. You can see here we were able to get AB by using our knowledge in trigonometry. So you can see here how the stationing of PC, PCC, and PT was solved by applying the formula given. And then, now that we have these data, we can move on in solving for the stationing of each point, that is by adding 20 meters to the first point that is divisible by 20 meters, and so on and so forth. In the first curve, we will be using the station of PC. However, when it comes to the second simple curve, the station of PCC will be involved. And then, when getting the sublength of the curve for each station, in the first curve, we'll subtract the station of PC to the stationing of the points. And as for the second curve, we'll be using the PCC instead of PC. Next, for the degree of the curve, we will substitute the values we got to the formula in getting the arc length, and then keep in mind in which side was the station located, as we will use R sub 1 for those in the first curve and R sub 2 for those in the second curve. Next is to get the deflection angle. We'll divide the sub-degree of the curve, in this case theta, to 2. And then is that lastly, we will solve for the subchord of the points, that is by substituting the values we got to the formula using r sub 1 means it is in the first curve, then r sub 2 for when it is in the second curve.
After all the calculations have been completed, the final answers are summarized in the tabulation part of this fieldwork, where it shows all the stations in the compound curve with their corresponding values in stationing, deflection angles, and the length of the chord from the PC if the station is found in the first simple curve, and from the PCC if the station is found in the second simple curve.
So at this point, based on the results and data acquired, the surveyors observed that the first and second simple curves create a compound curve and meet at the point of compound curvature. The point of intersection of the compound curve was derived by summing the points of intersection of the simple curves, and the first simple curve has more curve length, radius, chord, and tangents than the second simple curve. The surveyors calculated the complex curve's long chord using trigonometry knowledge such as comparable triangles and sine and cosine laws. And after analyzing the data, it was determined that the first simple curve had more stations than the second simple curve. This could imply that as the deflection angle grows, so does the chord length and the arc or curve length for the two simple curves. So basically, in laying out a compound curve, we use the concepts of the simple curves, and by deflection angle, we were able to determine that as the deflection angles increases, the curve length and the chord length of the two simple curves in the compound curve also increases. And in this activity, we were able to use the basic trigonometry knowledge such as triangle similarities and the laws of sine and cosine. So, as a conclusion, laying out a compound curve influenced by the use of angles of deflection shifted from tangents to points along the curve at the point of curvature. Therefore, the curve is formed by moving pegs at a regular interval equal to the length of the usual curve. Typically, the subchords are positioned at the beginning and at the end of the curve to change the actual length of the curve. One application is on railways. For example, the old railway in Danao. The railways are designed for the safety of everyone, wherein the knowledge in this is helping what sharpness of the curve to be used when turning. So the importance of studying this application in the real life context, because it is important because it affects the safety of the construction outputs, especially on railways. So that's it. Thank you for watching this video presentation. Have a nice day.